Welcome to the Micronaut podcast. The Micronaut podcast is a show about the Micronaut framework. Micronaut is a JVM framework which allows you to build any kind of application, from CLI application to traditional backend services to microservices or even serverless functions. I am here today with James Kleeh, who is the Micronaut product lead. How are you, James?
I'm great. How are you?
I'm fine. Ready to take holidays for Christmas. We are recording this a bit ahead of publication schedule, so we'll publish this podcast in 2022, and we are recording it in just before Christmas. So Happy New Year to everyone, I guess. By the time you listen to this,
tomorrow's my my last day, and then I'm off until the end of the year. So it'll be some good time spent with family and that kind of.
Same for me. So we are going to talk today about security, which is a topic that James and myself have worked a bit in Micronaut. But before talking about security, let's kick off with the agenda. So for agenda, and speaking of security, we have an upcoming training the 10th of January. I will include a link in the show notes. It's essentially a 4 days, 3 hours a day security training with yours truly, and we will cover you everything that you need to know to get started with Micronaut Security and who doesn't need security in your application. So if you have time, please join me on January the 10th. That week, we have another training on Friday the 15th, which is Micronaut testing tips and tricks, which is just 1 day. If you register for the security training, you get that one for free. Again, I will include a link in the show notes. For those who are coming from Grails, or who are still using Grails, or who are using Micronaut and Grails, we have an upcoming Micronaut and Grails training in February. I will include a link in the show notes as well. And if you are in Europe, Graham Brochet has a talk in JFocus in Sweden in February as well. So I will include a link to that one. And with that, let's get talking about. And today I have a level up tip prepared. So level up is these small tips where we essentially tell you like some methods or classes or features that you may not be aware of. One of them is if you are using Micronaut, you are probably using the Micronaut HTTP client, and you know that the Micronaut HTTP client has a fluid API. So essentially, we have static methods for the HTTP verbs. So we have like a static method called get, one post and one put and delete. And if you want to like set up a header, you can do like HTTP request.post, and you specify the URL and the body, and then you do like .header, and you can specify a header, and you may need to use either bearer authentication or basic authentication. What that typically means is that you have to specify the authorization header. So the header name, your HTTP header name, is authorization, and when you are using basic auth, that means that the value for that HTTP header is basic and space, and then the username, semicolon, and the password. That combo, username, semicolon, and password, you do the base64 encoding of that. So essentially it's basic and space, and that base64 encoding, and that will be what you have to create for a basic auth header. And for bearer, typically you have as the value of the authorization HTTP header, you have bearer, the word bearer, and a space, and then you have a token. In Micronaut, to make it convenient, the HTTP request class has two methods. One is called, I think it's basic auth, or basic, I think it's basic auth, which has two parameters, username and password. So you don't have to, we take care internally in that method of doing the base64 encoding and the basic prefix and all of that. So you essentially pass the username and password, and we do the rest. And for bearer, we have like bearer, I think is the method name. And you essentially pass the token, and we will prefix the token with the bearer and a space. So if you are using each one of those, and you probably are, don't write manually those .header authorization. Just use those two methods, which are at your disposal in the HTTP request. And without further ado, let's jump into the main section. And for the main section today, I wanted to talk about security, which is a big module in Micronaut. And there are many things to talk about, James, so it's difficult to start. One of the things that I want, let's start by this. So how do you, we have many security dependencies. The main one is with the Maven coordinates is io.micronaut.security, and the artifact ID is Micronaut Security. In the moment you add that dependency in your application, all of your controllers will immediately return a 401. So everything is unauthorized, right? So and why that happened is because when you add that module, we add a security filter, right? So you know that in Micronaut we have this concept of server filters, and the server filters can intercept all the requests before they arrive at a controller. So essentially, filters are ordered. Can you explain a little bit about the ordering of filters? Because there are like different phases, and a user should register the filters in their correct order.
So Micronaut has a concept of server filters, which are not specific to security, right? Like, so the security module just has an implementation of a filter. And it can be quite difficult to sort of know where to place your filter, depending on what you want to do with it. So, for example, if you need access to the currently logged in user, you would need to make sure that your filter executes after the security filter, right? And so there could be other filters that you want to make sure your filter executes before or after. And so we've created a really I think pretty simple to use class called server filter phase, which has different phases in it. Like I think there's like tracing and security, and there's I think 7 or 8 of them or something like that. And so you can say, when you create your filter, you can override the getOrder method, and then in that getOrder method, you can say server filter phase dot security. And then you could say, after that, you could say dot before or dot after, right? So those are methods on the phase itself. So that's an easy way of just ensuring that your filter executes before security filter, right? And so you can just say server filter phase dot security dot before. And then you don't have to worry about like what the specific order actual value is, right? It doesn't matter if it's 500 or 5,000 at that point, right? And if those numbers ever have to change in the future, then you can always be certain that be executed at the rate.
Correct. One thing that James pointed is, and whenever you have like, if you are designing like a library, a Micronaut library, and you need like to have like multiple bins of a type, and you need to order, we have a class, an interface in Micronaut called ordered, which you will see that we use it in many places. And one of these places is the HTTP server filter. And we have also like a utility class called, I think it's called sort utils or something like that.
Order util. Or
order utils, which will essentially like give you like a comparator for any class implemented in that interface. So if you are like writing a Micronaut application and you need to think about the ordering, think about the ordered interface. But that's like a really simple interface which has only one method called getOrder, which has a default implementation. So that's like really something that is like really harmless and easy to use. And we use it a lot through the framework. So that's a pattern that you will see.
Yeah. And the places where it's not possible to implement that interface, we have an annotation called @order.
That's correct.
And then you can apply that. That's mostly, I think, used for things like factory methods where you're returning classes that you perhaps don't have control over. You can just annotate the method, specify the order for that bean.
We just laid the ground, so you install Micronaut Security and you have the filter there, which will evaluate every request. So essentially what we want to do is, there are a couple of decisions that the filter does, right? One decision that it does is it searches the request, and that means the headers or maybe the query value parameters. So imagine if you have like your application, you want like to have like an API key as a query value parameter, you could write that in Micronaut. So we are essentially like searching, we are trying to infer if we can, we have this concept of authentication fetcher. So essentially, given a request, we try to see if there is a user authenticated, right? So let me explain it easy. So if you have like a bearer token, so if your request contains, you are receiving a request which contains the authorization header, and it contains a JWT, for example, in the as the value of that HTTP header. You know that a JWT is like self-contained, so we can essentially like vary the signature of the JWT. We can get the claims of the JWT, and with the claims we can build this object which we call authentication, which essentially authentication extends from JavaX security principal, I think is the package, or maybe it's not X, I don't remember anymore, but it's the principal class in Java, which essentially has one get name. So it's like kind of the username, right? And in authentication is like a kind of a container, which has also attributes. So for attributes, things like, I don't know, you could have like the email address in the claims or anything, or the favorite color of the user. Another typical thing that you will have in the claims sometimes is the roles. So you have the ability in configuration to define like for JWT claims, for example, this is how you get the roles. So the filter will search in the request and try to get an authentication object, zip with multiple authentication fetchers already. But let's go later about authentication fetchers. So one thing that the filter does is we essentially attempt to get an authentication. It could be that there is no authentication, right? So it could be like the request comes and there is no token or anything. That's like for us, it's like an optional. It could be like you either have an authentication object or you don't. And then we do evaluate what we call security rules. Can you explain what security rules are?
Security rules are it's an extensible API that allows you to determine whether or not a given request is authorized to continue, right? And it's a really flexible API in that you have access to the authentication, right? Whether it's there or not, right? So it could be null if it's passed in. You also have access to the whole request. So if you need to check data beyond just what was passed in the authentication. And then you also have access to the route match, right? So when a request comes in, it gets matched to a route in your application, right? So if it matched to a specific route, then you'll have access to that route match as well. And so you'll have access to know like what was the method, what are its parameters, and the most important thing being there, what are the annotations on the route, right? And so that we provide a whole bunch of different implementations of security filter, but the important thing to know is how Micronaut Security responds to what you return, right? So security filter, the security rules return one of three things: accept, reject, or unknown, right? And we basically go through the list of filters of rules, and they're ordered, right? Just like we talked about, the filters are ordered. So the rules are ordered, so you can change where yours appears in the list. And if one of them returns accepted, then that means the request is then authorized, and no further rules are then checked. And if one turns rejected, then the request is rejected and no further rules are checked. And then if you get through the whole list and all of them return sort of unknown, then based on a configuration setting, the default is the request is rejected, right? And so the some of the default implementations that we have are for example, there's a secured security rule, right? So we have an @secured annotation. So you can apply that to your method, and then we have a security rule that looks at the values in that annotation, and then compares them to the roles in the authentication. And then, so if the roles in the authentication, match what's in the annotation, then it's accepted, right? And it's authorized. And so there's a lot of really sensible defaults there as far as the security rules that we provide, but you can absolutely add your own security rule. For example, for a company, I implemented a security rule to support resource-based authorization using something called, I think it was called Casbin, if I'm remembering right, and where you basically say this person has this permission on this resource, right? And so we created an annotation to put on the routes to say this is the resource, and then here are the permissions that you need, right? And then I created a security rule that read that data and then compared that to the permissions that the user currently had, right? So it's a really extensible API, and it makes it pretty easy to write your own sort of logic if you need it.
Exactly. So again, the order pattern there. It's important that you see that the security rules are executed in order, and as James said, if any of these rules return either accepted or rejected, the security rules below that rule will not be executed, right? The request will be either let get passed through or denied. James mentioned the @secured. We support also the Jakarta annotations such as @permit all or @roles allowed. So you don't have to use the Micronaut annotations. You can use the more standard annotations. It's actually the same thing as if you are using ours, because we are essentially using one feature in Micronaut called annotation mapper, where we can map one annotation to another one. And that's a nice thing, because this allows us to essentially allow users to use a lot of these standard annotations, where a standard annotation exists, which is not everywhere.
Yeah, you just have to make sure to have security annotations on your annotation processor class path.
Thanks for pointing that. That's a different dependency. So we said like Micronaut Security, that's like the core of the security module. Then the security annotations will essentially contribute all these annotation mappers so that you can use the permit all, roles allowed. And we support, I think right now we support both the Jakarta and the JavaX. So please move to the Jakarta annotations, but we are still supporting the other ones. So at this point, so in security rules, James mentioned we have, for example, one for using an annotation-based security. So you will have to go through all your controllers and decide which annotation do you want to use. If you don't want to use that, you can use what we say is called the intercept URL map, which essentially is you are defining that security configuration in the application.yaml file. So if you prefer like not to have security configuration in your controllers, you can absolutely do that and do all the security configuration via all the security requirements via configuration. The @secured works as a method level in a controller or as a class level. So you could have a controller with multiple methods annotated, one with get and another one with post, and you could have like permit all at the class level. Once you arrive to a controller, we will talk more about the token fetches and token validator. I have not forgotten about that, but I want to go like the route. So we went through the filter. One of the security rules let the request go through, right? And we arrived at a controller. If in the controller you need to get access to the currently authenticated user, you can use as a method parameter either authentication or principal. Both things, we bind it. That's a feature that is really useful, and probably many users don't know that feature. What's the ISA request type argument binder, or what's the class that we implement is?
Yeah, it's typed so that there's basically the way that the arguments for controller methods are created and essentially attached to the execution is through an API called argument binders, and we have an argument binder for authentication and principal, so you can just specify that as an argument to your controller method, and then you have access to it, right? If the controller method allows anonymous access, you just need to make sure that the argument is nullable.
Correct.
Right? Depending on which language you're using, that depends how you can define that, right? In Kotlin, you can just make it a nullable type. For Java and Groovy, you can just add the nullable annotation. And then then it's like sort of an optional parameter.
My point is, if your organization have an authentication representation, which is like kind of more defined, imagine you have an authentication which contains always username and email, and you don't want to use our authentication object, you can create like your own Pollo and create an argument binder and essentially get like the object with the format that you are used to with your organization fields, and that's quite powerful. So yeah, think about it whenever you are like if you are in a controller and you wish like you had like you could bind part of a request to a particular object, think about argument binders, because that's a really easy to use API as well.
Yeah, they work based off of annotations as well, right? So if maybe you just want to bind like a string or something like that, you can put an annotation on that parameter and then have your binder target that annotation instead of the type of the argument, bind that argument from whatever data that's available.
That's, for example, what happens when you bind like an at header, right?
Yeah, at header, at body, any of those sort of annotations that we have, they care about that the annotation is present on the argument, not necessarily what the type of the argument is.
Exactly. We arrived at the controller, and this is like how to, going back to the filter, where we talk about authentication fetchers. So you can create an authentication fetchers. The API is really simple, and you could like always create your custom authentication fetcher and return an authentication given the request. But we provide one which so the framework ships with one, which essentially will try to search for tokens, and we have an API called Token Reader, which will essentially search for a token in the bearer token, a token. I think the basic auth is we have a basic auth token reader by default, and that authentication fetcher, which is the token resolver, will have like we have an API to read the token from the request. So imagine you read the token, which is like the bearer token, which I am always saying that is like a JWT, but you could have like an API key. So imagine if you create an application for each user, you create an API key, a random UID, and you ask the users whenever you consume my API, you have to send the this API key in this particular HTTP header, right? So you could create a token reader which reads the token, and then you can create a token validator, which is another API. And essentially, the token validator will get a token if we were able to find one and try to validate it. So if I continue with my example of the API, you could have a token, an API key token validator, which goes to the database and searches if that particular API exists. In the case of JWT, and this is another module, if you install the security JWT module, we have a built-in JWT token validator, which will essentially attempt to validate a JWT with the signature configurations that you provide in your application. So we supply you with an API to configure different ways of JWT signature configurations, and we will essentially go through all of those signature configurations and attempt to validate the signature. And if we validate the signature, then we will essentially we have the JWT token validator will have it has all the components to create an authentication given the claims. If that is not what you need, you can always override parts of this API. So as you see, the thing is it's pretty modularized. You have token readers, token validators. And if any of the things that come in the framework don't work for you, you can always change them, for example.
Security, I think by far is our most extensible module, right? Given how many different requirements people have for security and how many different setups there are and just all of the different possibilities that are common right out there in the wild. Basically every single decision point or process is extensible in Micronaut Security, so you don't have to think that you're constrained by what we provide, right?
No, absolutely no.
You can always write your own code to do it.
Yeah.
Either replacing the entire process or just modifying parts of the process.
Yeah, we explicitly have many classes where we have designed the API with protected methods, so that you can extend one of our implementation, add the add replaces in your class with add singleton, and essentially override a particular method that you need to replace to essentially suit your needs. So the API should be really flexible. I am thinking, for example, we have one class called, I think it's called JWT Claims Generator, which will essentially contain a bunch of protected methods to essentially populate your claims. And that's really difficult to essentially because everyone has different requirements, right? So we will essentially give you a lot of freedom to override those methods or provide your own implementation. But essentially, there are many. As James said, that's 100% correct. We have tried hard not to constrain you, so you should be able to adjust the security module to suit your needs.
It also has another really nice benefit of that. It makes testing pretty easy without actually having to really mock. So you can, in your source test, you can create an authentication fetcher, for example, that compares, some predefined username, right? So if you pass in the username, John, then you'll be authenticated with admin role. So you can test, test your security with some sort of mock users by creating an authentication fetcher in your test environment. Yeah. So how extensible it is makes it really easy to sort of not have to, log in with real accounts and that kind of stuff when you're just testing your APIs.
So one of the things I wanted to talk also was about the login endpoint, right? So one thing is to log in an application, and another thing is to get a request authenticated, right? So what we discussed before is requests are authenticated because they essentially contain either in headers or in query value parameters, we are able to extract some information. For example, for session-based authentication, when you are using session-based authentication, you had a header with the JSession ID typically is called, and you have essentially that's the session identifier. So when your request arrives into the Micronaut server, we essentially see, okay, there is session ID here. We go to the session, we get the session for that particular ID, and we search for an authentication user in that particular session. And if they are, we essentially inflate it.
Yeah, that's an example where there's actually a filter that will look up or create the session based off of the header value, and that filter has to execute before security, right? Because we have the option of looking for the authentication in.
Exactly. But how that's at what point do we save the authentication in the session of the user? And that's what the login endpoint is, right? So when you are using the login endpoint, we support, we call this setting, and hopefully this is something that we can convey in this podcast. We call this setting Micronaut Security Authentication Mode, I think it is. Let me search for it. but I'm pretty sure, and we convey several. We ship a couple of different authentication modes. One of them we call it bearer. Another one we call cookie. And another one we call is the property is Micronaut Security.authentication. And we have like session, we have bearer, and we have another one called cookie. So essentially, if you, and this is something that you have to provide. So we have a controller, which Micronaut Security ships by default, which is the login controller. And some of these built-in controllers in Micronaut Security, they are not enabled, they are not loaded, unless you have beans of a certain type. So the login controller, for example, requires you to have a bean of type authentication provider. And it requires you to have a bean of type login handler, right? So authentication provider essentially will receive, so the login endpoint typically will take a username and password. It will take credentials. And those credentials will be passed to the authentication provider, which is an interface which essentially will return like I think it's a publisher authentication response, I think is the object, which will essentially contain either a failure or an authentication within. And that's typically the place where you will, for example, given a username and a password, you will go to the database and essentially like encrypt the password that was sent to you and compare it with the thing that you have in the database. Or you could have something even simpler with this. Imagine you only want to support one user because you only have one screen that you want to. You could compare this with some configuration values that you have. So this is essentially something that will depend from application. For example, one thing that we have also is, and I think you wrote that part, James, is we have support for LDAP authentication, and we have an LDAP authentication provider, for example, right?
Yeah, you can actually specify multiple LDAP servers, and you can just specify one as well, obviously, and configure. Set up the configuration for your specific LDAP stuff just in config, and then an authentication provider will be created for each of those LDAP servers. And so if one doesn't work, then we'll try the next.
Yeah. For LDAP, it will be one of the scenarios where you will typically not write your authentication provider. You will use the one that we ship with. For other things such as database authentication, because that depends so much from application to application, you will have to write your own. But for LDAP,
yeah, there's no like sensible default on we have no idea, are you using Mongo, or are you using MySQL, or are you using Neo4j, or some just Redis, or whatever, right? So it's not really feasible for us to create an authentication provider because we don't know what database you're using, where your users are stored, and all that all that information. So that's where you have to plug in your implementation. But then that's basically it, right? The rest of it.
Once you have the authentication provider, the other class that you need is the login handler. I want you to think about a login handler. That's essentially a bean that will say how do you essentially send the authentication information back in the HTTP response. So when we set when you set Micronaut Security authentication bearer, we are essentially enabling one login handler, which will respond as a JSON payload in the login endpoint. And the JSON payload will contain, if you are using the JWT module, it will contain an access token. If you have the required configuration for refresh token, it will contain a refresh token as well. If you are using session-based authentication, for example, and you set up Micronaut Security Authentication Session, that will enable the session login handler. And what it will do is it will take that authentication, it will save it in the session, and in the response, we send back the session cookie with the ID of the session. And then because the way browsers work, where each subsequent request will contain the cookie, you are immediately authenticated, because when you hit the server, as James said, we essentially are like looking for the session with that particular ID, and then you will have like a session authentication fetcher which will fetch the authentication from the server. Then we have another one which is called Micronaut Security authentication cookie, which right now it essentially will... We have actually one feature request which we will implement, but right now what it does is it will assume that you want to redirect, and it will save the authentication in a cookie of the response. So we will send, typically we are using JWT, we will save a cookie named JWT with the access token, and we have some redirect configuration. So if you search for a redirect configuration in the Micronaut Security, you will see like when I am authenticated, I am redirected to the home page. And if for example, I try to authenticate with a wrong password, you can say you are redirected again to the error page. Or if you are like, so that there are a bunch of different redirection configuration that you can set up. So as you see, there are two things that you have to think about: authentication provider and login handler. For login handler, we ship with several implementations. So one thing that I recommend you to do is search for login handler and see in your ID the different implementations that we have, and see if they are what you need. And if not, you can always write your own and tailor it to your needs. And we have a similar thing for logout. So once you are logging, we are essentially like sending you a token somehow. For session, it's not really a token, but a session ID, but essentially it's like kind of a way to get the authentication from the request. From logout, we have the same concept. We have a logout handler that we have some. So if you are using like Micronaut Security cookie, the logout handler, for example, when you go to the logout controller, it will remove the JWT cookie. If you are using session-based authentication and you go to the logout, it will essentially remove the session cookie and essentially terminate your session, right? If you are using bare authentication, it will do nothing, because we are essentially not. You don't have anything. You are like sending every request. You are sending the token in the header, right? As you see, many ways of customizing the behavior of the solution, and we have a couple of other controllers. We have another controller for the refresh token. So check it out. The refresh token is something that we improved a lot in Micronaut Security 2, I think was. And again, this is another place where everyone does refresh token differently. So you will have to write a couple of bins because there is no sensible default there as well.
Yeah, because it requires persistence, right? Like in order to validate a refresh token, it requires it to be persisted somewhere so that you could look it up later and determine whether or not it's been invalidated or whether it exists at all. And then that's also the way of determining who the user is, so you can regenerate authentication data for that user. So that requires you to sort of fill in the blank.
So the last part that I wanted to talk about was our OAuth 2 solution, and we support a couple of grant types. How do we explain this, James? So we support 3 flows. We support authorization code grant type flow, which is the typical flow where you are used to, which is you go to a website and you see a button which says sign in with Google. You click that button and you are redirected to Google. You enter your credentials and you are redirected back to your application. So we support that, and we actually support that with really minimal configuration on your site. Typically, all these authorization providers, they will give you like a client ID and a client secret, and they will give you like a URL where you can, when Micronaut will get the configuration of the remote authorization server and configure itself.
For OpenID. For
OpenID Connect. And if, for example, if you are using GitHub, which doesn't support OpenID Connect, or the last time it wasn't supporting it, you can define like the token endpoint and what was the token endpoint and the authorization endpoint. So you can configure those details manually if you don't have like OpenID configuration exposed by the authorization server, we have some really nice guides explaining these steps. So we have guides for signing with Google, signing with Okta, signing with Auth0, signing with GitHub, which is what James was describing, which is an authorization server. You have to define more the endpoints manually. We have also one for Cognito. We have example for a couple. We support another one, which is a weird flow, which is the password flow, which essentially means that the user is sending you their credentials. So it's not ideal. There are some scenarios where this is the only available option, but this is not the ideal scenario because essentially the Micronaut application is seeing the user credentials because they are going through the Micronaut application, right? So if you can, essentially the way it works is the user sends the credentials, we see the credentials and we send them to the authorization server and we authenticate and respond the user. So that's not ideal, but that's a flow that we support. I have seen some use cases, for example, in some podcast applications, for example, they will allow you to have like private feeds, and the only way they can do that is by supplying username and password via basic auth in the request. So if you want to use an authorization server, that will be your only option for that. And typically what people will do is they will create like separate credentials for this thing. So it will be like the user will have kind of two sets of credentials, like these more or less unsecure credentials that they can pass around and their real credentials. And the last and interesting flow that we support is the client credentials. Can you explain a little bit what the client credentials flow is? And
So Sergio did a lot of work on the client credentials stuff, but basically it's you're logging in to the provider with your client ID and secret to authenticate some request to their API, usually. And what's difficult about doing that is that you get back some token, right? Or you get back some piece of data that you need to pass in for future requests, right? So usually it's like some type of token, and that token has an expiration. And so managing, okay, well, where do I put the token? How do I know if it's expired? I have to, when it expires, I have to go re-authenticate again. It's difficult to manage. And so what we've created is a client filter, right? So Micronaut has the notion of server filters, but we also have the notion of client filters. So based on some configuration that you supply, when you make a request to that URL for the that we know should be authenticated with client credentials, we will, instead of making that request immediately, we'll first make a request to get a token, right? And obviously part of that is checking to see if we already have a token and if it's expired and that kind of stuff. But assuming we don't have a token, we'll first go off and request a token, get it back, put it into your request, and then send your request off, right? So you don't have to be concerned about getting the token or when it expires or anything like that. You just make the requests and it happens automatically. And there's obviously a lot of configurable points in that and points of extension that you can customize the behavior and that kind of stuff. But overall, it should work pretty transparently.
Yeah, client credentials is a flow for machine-to-machine communication. So the idea is you will typically use authorization code grant type flow when the user needs to authenticate. But if you have, imagine, two Micronaut applications and a third application, which is the authorization server, and you want to send requests from one Micronaut application to the other application, and you want that communication to be secured, right? Both applications, they know how to validate tokens from the authorization server, right? So what you will typically do is that both applications, they have like client IDs and client secrets. They have, and they are able like essentially get a token from the authorization server and send the requests between them using that token. And for you as a user, it will be transparent. You will do it like during HTTP requests with a normal Micronaut HTTP client, and we will essentially, as James was saying, we will decorate the request with an authorization header with the access token that we obtain via the client credentials request to the authorization server. That's really powerful because it's really like kind of you have both ways. So you have like a secure communication, but your code is really not dealing with security, so you don't have like to get like the token and do all of that. That's transparent for you. And as James said, there is like many configuration points. We have a couple of guides for client credentials. One is with Auth0 and another one is with Cognito. So if you are using client credentials or you want to use client credentials, please give it a try and let us know if you find anything to improve. And I think that's pretty much the overview that I wanted to cover about security. Am I missing anything, James?
No, the only thing I'd like to add is that we support regular OAuth, OAuth 2, and OpenID, but the underlying API could technically support any three-legged flow, right? And by three-legged, I mean we redirect to some provider, and then that provider redirects back with some information, right? So I actually wrote, so I think Twitter, I mean, this is at the time, this was maybe a year and a half ago, but I think Twitter at that time only supported OAuth 1.0, and I was able to write an OAuth client to log in with Twitter with Micronaut, right? So even though it's not part of the standard that we typically support, the API is flexible enough that you could technically support any three-legged.
The last feature that I want to point people about is we support also token propagation. The idea here is that you have a service, you receive a token, and you can automatically, imagine you have like an application with 3 microservices. One is the gateway, which is calling another service, and you receive a request in the gateway with a token. And when you do a subsequent request with an HTTP client from gateway to your persistent service, you can use one feature that we have called token propagation to essentially take the token that you got in the initial request and propagate it in the subsequent request. So again, this is kind of having secure communication between microservices, but getting out of your way while you are writing your application. I think we are going to wrap it for today, James. We have a lot of Micronaut guides in guides.micronaut.io, which covers security, and that will be my mention in the guides and section content. So we have many guides covering security. Check them out. Give us feedback. As James said, the Micronaut Security module is one of the biggest modules, probably with Micronaut Data is the biggest module with Micronaut Data. So there is a lot there.
Yeah. If you have any questions, come hang out with us on Gitter, our Gitter channel, and be happy to answer any security-related questions.
This episode was brought to you thanks to the Micronaut Foundation. Many thanks to our corporate sponsors, our ambassador sponsor, Object Computing, and our 2 bronze sponsors, Safri.net and Visor Games. Also, many thanks to our community sponsors, those individuals who support the framework via donations. Individuals such as Corbinian Balch, Gis Loisnik, Lucas Morachev, Jen Weiss, Jeff Scott Brown, Danilo Marquez, Edgar Rios Navarro, Goran Eriksson, Andrew McKee, Balasubramanian, Rengasamy, Philip Eisenbach, Hassam Muhoudini, and Jason Silder. Many thanks to all of you. And if you are interested in supporting the framework, visit micronaut.io/foundation. Again, many thanks to all of you for listening to the podcast. Many thanks for our sponsors for making this so possible. And we listen to each other in 2 weeks. Thanks for listening. Thank you.